Hi everybody, Ms. Dietrich here helping you on Lesson 28, which is on two-step equations from Module 4 of Engage New York. Question 5 is a little complex, and the reason why it is because they're talking about 3 different strokes and there's a lot going on here. We're going to take a look at how we might use a tape diagram to help ourselves understand the question. Justine swims freestyle at a pace of 150 laps per hour. Justine swims breaststroke 20 laps per hour slower than she swims butterfly. If Justine's freestyle speed is 3 times faster than her butterfly speed, how fast does she swim breaststroke? Let B represent Justine's butterfly speed and R represent Justine's breaststroke speed. Now the thing we're going to work on first is we're going to figure out the butterfly first, and we'll do the breaststroke after because they give us a clue that ties in the freestyle with the butterfly, and the clue I have that highlighted in yellow. We know that Justine's freestyle speed is 3 times faster than her butterfly speed, and we do know her freestyle speed is 150 laps per hour. So that means that we can create a bar which is going to be 150 long, and we know that the butterfly is going to be, we need 3 of those to equal 150. And if we write an equation that represents that, it would look like this. 3 times B equals 150. If we solve that, each of these b's, we have to think of what number that would represent. The opposite of multiply a variable by 3 is to divide it by 3. So we would divide by 3 on both sides of the equation to keep it balanced. And if we do 150 divided by 3, we're going to end up getting 50. All right, so that means that this piece here is 50. That's just this piece. Now the reason why we need to compare that piece with another piece, which we're going to read again, there's another clue in here. Now let's think about what the tape diagram for the other stroke would look like. Now here's what we know. We know that if we compare, because remember R is going to be standing for the breaststroke, so the breaststroke plus 20 would have to equal the B, the butterfly. And where do we get that from if we look at the problem? Right here. Justine's swim breaststroke is 20 laps per hour slower than she swims the butterfly. So if this represents that stroke, we'd have to add 20 to that to get this value for R. So if we know that this is equal to 50, this whole thing, some number plus 20 has to equal 50. Doesn't that mean we'd have to subtract these two things to get the value for R? So let's take a look at the equation for that. We would do R plus 20 equals 50. The opposite of add 20 to a variable is to subtract 20, and we're going to do that from both sides of the equation to keep it balanced. And then if we solve, we get 30. So let's plug that in, look at it on the tape diagram to make sure it makes sense. So we believe that this number here is 30, and we know that she's 20 laps per hour slower for that stroke, so that makes sense. All right, so if we think about the answer to the question, we know 2 things. We know she swims butterfly at a pace of 50 laps per hour. We were able to figure that out right here. And we were able to figure out that she swims breaststroke at a pace of 30 laps per hour. So you would want to reread the problem and kind of put those numbers in and make sure that it makes sense. And if you do that, you're going to find that it makes perfect sense.